try to explain how the motion of the platform is being created. And the first concept you have to get into your head is this. Let me take a look here. The concept of a doll being inside a doll, inside a doll, inside a doll, inside a doll. So one object is stacked inside the other. And that's an important concept to understand when you talk of motion simulation, because we have plenty of other objects that are stacked inside of each other, and I would like to create them from the ground up if someone is interested in understanding how this works, at least in my case. So the first object is the rig. It's everything there is to the rig, and it's an empty object. There's nothing in here. It's just to hold the whole thing. So the first object in the hierarchy is the base, and if I activate it, then this is what it looks like. It is a platform, and it is in this position, and here are two interesting properties. It's a platform, it has all these properties, and it has a transformer, but that's the one that moves it around, but it doesn't do anything. That doesn't need to be there. It doesn't have any streams driving it, and it doesn't have any gains, all zero. It's static. It doesn't move. That's why it's there. It's only there to hold another object, and inside that base, think of it as a box, and inside that box, or matrushka, there is the platform height, and it lives inside it. And let me activate it, and if I activate it, you can see it, it's up here. It's also a platform, but it doesn't have any stream, so it's not being driven by any data stream. The gains are all zero. It has only this one property, offset heave. It generates an offset, so whatever happens from now on is being offset towards the top. In this case, 1.34 meters. That's its job. That's all it does. Now, inside that platform is another platform, and I call it the platform motion low frequency content. This is when the thing tilts back or rolls to the side, but it's low frequency content, so it's low pass filtered. Only the long lasting accelerations will be displayed in that platform. So let's look at that platform. It's here, it's identical to what you see here. And it's being driven by these two streams, the pitch and the roll stream, acceleration in X and Z direction, low frequency content, they drive it, these are the gains, and that's it. So if you imagine you were accelerating and this thing would pitch back, then you would feel the thing tilting. So this is kind of what happens when you accelerate. This is what happens when you decelerate. It's a platform that lives inside the other platform. Now, inside that platform lives this platform, which I just noticed is activated already, but doesn't matter. Okay, so here it is. That's the platform motion high frequency content, which lives inside the low frequency content, which lives inside the platform height, which lives inside the base, which lives inside the rig. So it's all stacked in each other. Platform motion high frequency content. This is the platform that displays all these forward, backward jolts, the little left and right bumps that you're feeling. This happens in this platform. And it's being driven by 6 data streams. It has sway, heave, surge, yaw, pitch, roll. All 6 are there. These are the gains. And if I want to move it, like imagine you had a little bump and you would generate an up or down heave. This is what This is what happens if you move up or down over a bump. If you have a little forward jolt, a surge, this is what happens. And it also can have a little left and right rolling action. So let's give it some roll and some yaw and some pitch if you want to. And this is all high frequency content, high pass filtered stuff. Only the short lasting pops that you can feel they take place in this platform. Now inside that platform lives another platform, and I call this the final platform. There's the one that you actually see. Let's activate it. And this again is not being driven. It just moves with its parent. It has only one job, and it's the offset heave in the other direction. And I gave it a minus 0.4 because it's below the center of rotation, which lives inside the high frequency content platform. Most people on the forums, they talk about putting the center of rotation above the platform. I found that pretty nonsensical. I put the platform below the center of rotation. This is how the hierarchy in this case works. And that way you can always be sure that the platform it's in the right position relative to the center of rotation. And then once this platform is being created, I have these actuators, and they have the job to pretty much just be lines between this point and this point. And that's how this platform comes to be. I'm gonna put them all back to where they initially belong in this loader saver. Load gains. The defaults, please. Offsets. The defaults. And the rig configuration itself. The defaults. And then I can. The final stays visible. The motion, high frequency content becomes. Stays active. It just doesn't need to be rendered. The low frequency content doesn't need to be rendered. The height platform doesn't need to be rendered. So that's basically all that's left. And yeah, when you move it around, then I can show it to you in action. Maybe I can make a video where it's side by side, where the aircraft or the vehicle is moving, and then you can see how the platform moves. So I hope you enjoyed it and learned a little from it. Of course, you don't need 4 of those, but I would say 2 are minimum. Otherwise, you run into problems with stuff interfering with each other. And I actually plan on doing a lot more of these platforms stacked inside of each other, because some I plan on using maybe a 7 or 8 for turbulence, for ground roll, for other effects, for aircraft stall, vibrations, buffets, and each of these actions get their own transformation and their own reference system in the hierarchy of events that happen. Okay, I hope this wasn't all too theoretical for you, and yeah, I'm greatly enjoying this, and maybe you too. Bye.